Welcome to the panel. We have a couple of interesting buzzwords to talk about: data science and prediction. So let's just do a quick one sentence, the difference between the two and the value. Maybe starting with you.
Prediction is always difficult, especially of the future. At the present time, these statistical methods can assess from large data sets how people have reacted or systems have reacted to the data. And in that sense, they can predict what another person, how another person would react. It is largely looking backwards in time. So it is not the ideal thing to do prediction of the future.
Great.
We work a lot in the life science industry. And we always say data in life science, where the order of complexity is significantly high, is deep, dense, and diverse. So we don't believe in the 4V or 5V view of the world. It's another buzzword. In terms of prediction, I think it's anathemic to the very concept of complexity. The world is getting more and more complex. Somebody told the other day, each day there are around 2,000 publications coming in the life science space. And there was another study that said a normal life science PhD in his entire PhD lifetime reads at max 3,000 papers. So it's just impossible to comprehend and understand everything that's out there, and hence almost impossible with a rear view mirror, as you just mentioned, using traditional statistical techniques predict the future. It's all about sensibilizing yourself with respect to the opportunity space. What can happen? You can't really put your finger and say this is going to happen. I think that's what business leaders need to understand and adapt their worldview.
So it's not a prediction, it's a guess. Is that?
Yes,
is that
it's a guesstimate.
Okay.
And understanding real options in terms of the strategic space, what can happen. And certainly most of these real options cannot be built looking at the history. If you look at oncology, the cancer space, neurology, some of the most exciting therapeutic areas, the kind of research we are seeing there, the degree of specificity and the order of complexity increases day by day. So just looking at breast cancer was one indication 6 years back. Now it's a group of people, say 40 different indications. It's not one disease anymore. So how can you look at your past historical data, sales data, market share data, or whatever is happening in the clinical development space and predict what's going to happen? It's just impossible.
So maybe starting with predictions. So nowadays we have so many systems to help us delivering something to people. So every single movement, automatic movement, is kind of a prediction. So it's like whether a machine will die, what to do with the job running on the machine, what to do, how to deliver, like for Amazon retail, how to deliver products to fulfillment centers, to users, how to have a huge variety of products, and who will buy them, and whether they should be stored in fulfillment center, and if so, then in which fulfillment center, how to optimize the whole system. So there are tons of predictions necessary to make decisions for now. It's not all about predicting future, it's all about running huge complex systems. And about the data, yeah, so nowadays we can track everything. So everybody has a mobile phone, and the mobile phone can track every single GPS coordinate. It can track every single movement, every single noise in your environment. So if you start to track that, then it's tons of data, and the huge challenge here is to make sense of those data. You can predict, you can store terabytes of data every second, but how to use them is the key concept.
Thanks. So it's interesting that none of you mentioned data science. You went straight into prediction, and then you talked about data and specifically statistical models. But predictions without actions are nothing, right? So how do we take those predictions and convert them into actions? Is that the biggest challenge? And let's try to keep each answer to less than a minute. I'm going to be like ruthless moderator.
Okay. I think you have been a little harsh on medical data. You know, it would be extremely helpful if the individual doctor had, on a statistical basis, on a learning basis, available to him all the experience of all doctors, of all cases of the last 10 years. That would focus down a possible diagnosis enormously, of course. There are still uncertainties, as you say, of course. It's not in the data. But as far as there are regularities, that can lead in the local case to a prediction of what this case might behave. Is not new to the world, but it's new locally. So I think when you talk about data science, there are regularities out in the world in certain fields which make this kind of prediction possible. And what I find so impressive about children, infants, they learn, it's extremely efficient how they learn in 2 years, 3 years' time. And the basis for that is that they have several data channels, vision and touch and self-motion and kinesthetics and so on, which start to make sense if you find a consistency between them. If your interpretation can be validated by your making trial movements and touching, and then you are absolutely certain about that. So this is a very benign kind of data structure, the nursery, so to speak. So, and one must hope, I think, that there are more cases like that in industry, in economy, and so on, that have this kind of self-consistency that help you to tease out inherent structures.
That was a long minute, but it was worth it.
Oh, I'm sorry.
It's okay. But let me just follow up on that for a second. I think if you actually analyze the amount of data that an infant collects, it's way, way greater by orders of magnitude than what we're feeding deep learning algorithms. So from that point of view, and not only that, it's multi-channel, you know, different context. One could argue that it's not very efficient at all. It takes years for...
No, I disagree. You know, if you count each fixation as one image, okay, you have 100 million of them a year. It's comparable to what you have in deep learning.
Taking cue from what you said, I always use this example. When I first came to Germany after graduating, and I started learning German, I would ask, how are you doing? And the people would say, nicht schlecht. And I would go to US and I would say, how are you doing? They would say, fantastic, I'm doing great. And I said, Germans are very negative people. But it's not true. With time, when I parsed a lot of data through my brain, even though I was not 14 years old, I came when I was 18 and a half, I learned to normalize nicht schlecht with doing great. And I think you referred to this contextualizing data. I think that's the starting point, and that's what data science has to be all about for specific verticals. You need to normalize data, you have to contextualize data for a specific vertical. And we use meta-ontologies and machine learning and other approaches to AI to do that. But once you have done that, only then you can think of estimating, guesstimating, or assessing the opportunity space going forward. I mean, all analytics, many people, and there are a lot of buzzwords and a lot of marketing dollars because AI is hot. Everybody is spending tons of money marketing stuff and playing with data, crunching data with high-powered computational engines. I don't think, and there is enough evidence that it's not going to lead anywhere unless you first figure out how can you provide context to all of that data.
Yeah, so I think the efficiency is a key word here. So basically to train a neural net to recognize objects, like whether it's a cat or dog, it costs us thousands of kilowatts. If a person would need thousands of kilowatts to recognize whether something is a cat or dog, it will take like 20 years to learn that. So machines, they have to be much, much more powerful in the meaning of making use of data more efficient as humans do. They don't spend thousands on kilowatt hours to learn something.
And the cats and dogs problem kind of amplifies when you are looking at life science. You could have 5 Gunjans working in oncology. How do you figure out which Gunjan is working for what? Or an EGFR could be a target in one context. It could be something else. It could be a biomarker in another context. So the same entity kind of takes a completely new avatar in a different context. So before even starting to predict something and look at associations, one has to first figure out what this entity in this context stands for. And so cats, dogs, of course, on the horizontal level, it's identifying entities is difficult, is a challenging task given the amounts of data, but in a specific vertical, the problem is even deeper.
So yeah, the efficiency problem, I think, is pretty fascinating because depending on how you compare, you might get different answers. I appreciate the answer you gave, 100 million, but then you could argue that that would take a year or 2, whereas you could train a deep network in a few hours without any additional context or anything else. So context is really critical. Is that the answer? But how do companies actually formulate that context so that the data science makes sense and they can make predictions that turn into actions?
So there are 3 challenges that we saw in the industry. People have taken what some of the people in AI space call narrow AI, narrow data science approaches. So there would be a big bang data lake project. Parallelly, businesses would try to have applications for specific use cases. It can't work because your capability with respect to crawling data, aggregating huge amounts of data as an incumbent, as a pharma company, as a hospital would be limited. The second challenge, and this calls for a general AI data science kind of an approach wherein a company like ours, it comes, crawls all the data that's out there and tries to organize that could be used by many others. The second challenge, I believe, is the financial markets challenge. If there is a pharma company or a bank takes a big bet in data science, tries to build something really out of this world, and loses a couple of $100 million, the stock price immediately takes a hit. But if a Jack Ma or if crazy guys like us, we try such experiments, and even if we fail, we'll be lauded by the community. So taking big bets is always a very risky gamble. And last but not the least, the IT organizations. I mean, what do you stand for? Keeping the lights on? Or doing the skunkworks, crazy, new data science, AI kind of stuff? And there is a fundamental problem in management science. We talk of ambidexterity with one organization, and now people are coming with chief digital officers. But what does CDO do? What does CIO do? Where one stops, where one starts? That's the third challenge, in my opinion.
So I agree that processes are really critical in companies being able to use data and machine learning and get on the bandwagon. Barbara, Amazon is amazing in many ways in using data and in the processes that it has. What kinds of insights can you give smaller companies in terms of how they can change their own processes to use more machine learning and more data science in terms of data collection and so on and so forth? What are the key components?
Yeah, I think it's like there is a huge difference between small companies and big companies. Companies like Amazon can just afford pushing tons of machines, thousands of machines, and computing something for, like, if you imagine you can improve your model by, I don't know, 1%, and you train on hardware that costs you, let's say, $100,000, and you save or you gain revenue of 1 million or 2 million a month. So that's a pretty easy calculation. So you can afford that. Small companies, they don't have the capital to invest first, like tons of money into computing some models. So this goes into direction reusability of what's existing. So not everybody has to compute everything on their own. So in computer vision now, the deep nets, they were trained for a particular reason, and now they are retrained or made better for other purposes. So it's like how to reuse what's existing, how to reuse what was calculated and done before for you. So it's like not everybody has to reinvent the wheel.
So in terms of process, there's been a bit of talk also about sort of the scientific process and how companies that excel at doing this and do a lot of A/B testing, collect data, measure things, can succeed. What can you say, Christoph, about that? Like the science and how to transfer those processes to industry, especially smaller companies?
Well, I've limited experience with running companies. I had these two companies that essentially did face recognition, and I can tell you what I plan to do in the company I'm about to build. I want to train a visual system with virtual reality, a computer graphic system as front end that will give me data. Very limited, you know, the nursery, the stable and limited, but rich in the sense of different modalities. I can ask ground truth. Where is this thing? How far is it? What material? What is the shape? I can get real data in order to train my system. I'm not sure that is a model for much of learning from data in industry. This is a very particular kind of situation, and the fact that children need 10 times longer to be able to drive a car or to write a check is an indication of the fact that the environment in which they learn, the societal, they learn about the things that are behind the horizon, where time constants are much longer and so on, their learning gets much less effective. And I think, you know, the use cases we have been talking about here or in the morning, they are of this latter kind, where it's very difficult to get at the data and very difficult to sift out. So I don't really know what you can learn from me in this context.
Yeah, so going back to children, I agree. And the thing that's really interesting, again, is that children and humans are learning many, many things at once. Whereas if you're training a neural network, it's just doing X, and that's basically it. So they're completely different, and from that point of view, we could say we're really, really far away from human learning.
Yeah, and I think it is a mistake that is avoidable. You know, much of deep learning has been done with single disconnected images. Leaving out continuous streams of images, let alone other modalities like acoustic and so on. So what makes our brain so effective is that it homes into those things that are for which the different channels are consistent with each other. And you know, the conscious state of our brain is one where the different modalities, the seeing, hearing, smelling, emotions, memory, language, are all in agreement with each other about the present subject. And this kind of multimodality is grossly left out, I have the feeling, at the present learning environment.
Yeah, so I agree with you. It has been left out for many, many years in the technical research community, and the reason is that it's just very hard to integrate all of these modalities. Nobody knows exactly how to do that. But the other thing is that in practice, in businesses, that's also very hard, as you pointed out. How can companies address those issues of having data that's siloed and all over the place? And how do you get started in data science or applying simple machine learning techniques? Barbara?
I think it's never easy. So it cannot be easy if you take so much data. So at Amazon we have one data store for all kinds of data, and everybody. So of course everybody who has permission to get some data from the data warehouse. But it's always a problem. It's always a problem to take the data, to clean the data, to make use of that data. Nowadays, we have so much data that we don't even know how to store it in a way that a person can go and take the data out, which the person needs and which the person has permission to, and use the data just out of the box.
We do it a similar way, but in a very simpler fashion. In 2011, when we started, we said we need all the clean data at one place, organized, aggregated using an ontology that we have a context. And then we went to businesses and looked at, I was in consulting before, and I saw you would do consulting projects that use similar logic every year. If it was about identifying key opinion leaders, if you're launching a drug, if it was about drug repurposing, et cetera, et cetera. So he said, let's map the human process of identifying the key opinion leaders. What do analysts sitting in India, China, and other countries do for all these companies? And then try to automate that process. I believe it's a better way, instead of saying, I'll take deep learning and I'll throw at every problem I see. Being more pragmatic, seeing what moves the cheese for the businesses, and try to reverse engineer what would it take to get the desired output, be it 90% automated, if not 100%, for businesses. That creates a positive momentum that builds credibility, and of course, that gives you more confidence in solving other problems.
So the reality is, in many companies, I guess you have two situations and everything in between, but one is, companies do have a lot of data and it's just a big mess and they don't even know what to do with the data. And then in other companies, they don't have the data, they don't even know how to get the data, they don't know why it's important. Are we relying too much on data? Is there a way to move forward without just waiting for the data to come?
I think you put your finger on the critical point. You said it would be nice to use multimodal data, but how would you integrate them? I think that is the central problem. If you had a data structure with which to express all those different things and a mechanism by which to integrate them, which our brain evidently has, so it is in existence. If you had that, then you could probably solve that problem. You small companies could live with rather sparse data sets which are rich enough so they make sense in themselves. So that could be the bottleneck through which we have to go.
Barbara?
Yes, so what our brains do, they have like automated garbage collection. So basically they throw everything away that they think they don't need. So the long-term, short-term and mid-term memory, at the moment in the automated way, we don't do that. So we store basically everything, every single data point and don't throw it away. So what we really need is the same mechanism for automated data, garbage collection and cleaning the data, making it compress it and store only the important parts.
So I think we're running out of time, right? So just a quick statement on privacy. Like, should consumers be more aware? Should there be like a data label, a warning label on your phone that says your data may be used against you?
Yeah, so I think it's education issue. So basically, people are afraid of clicking something on the internet, but they are not afraid to have a mobile phone that can hear you, that can do everything that all the other modern devices can do. So I think education and probably a bit of visibility how data is used and how companies are selling and buying data.
A little bit.
I think one needs to be pragmatic. In Europe especially, we see people don't care about searching something on Google, talking on Facebook, sharing WhatsApp messages, but when it comes to having their medical records shared If it's about creating a registry which is uniform, everybody says, no, 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 my disease is something private to me. I think if you'll share your medical information at an aggregated level, if you'd be more open to that, it would help you in return significantly more. So I think this awareness, there is some sort of, dilemma in understanding what privacy is. Where does it really help us? Where does it not help us? And there is this bandwagon that always says, no, privacy is important, without really saying, where it is important and where it is probably helpful not to care too much about privacy.
What bothers me most about this is that it is so completely intransparent where my data end up. If that could be made more explicit, if I want to have a personal assistant in my pocket, I have to allow it to know what my travel plans are and so on. I want that, but I want that to be confined in a vessel that is mine. And so I'm waiting, I must say, for the foundation of a consumer-concentrated company or movement, probably, that takes care of this kind of data containment.
Great. I think we can't wait. I think we have to do it ourselves. Maybe you have time for a couple of audience questions, do we?
Yeah. So, hey, thank you for the talk. You're talking about data all the time, but not about information. And why? Because information is the most important thing, and not the data. It's not the same. No, no.
I believe you, but I have read many articles about what the difference is, what information is, and so on. I don't see a clear picture. I think what the brain does, it extracts from the incoming data a kind of summary. There is a psychologist, I cannot find a citation of him, once said, with each experience we take in 100 bits of information. All the rest is thrown away. That's maybe what you call by information, the sifted out essence of something. But I don't think we have the technology yet to do that in any automated way.
Okay, thank you.
So I'll just disagree with that one. I think that's what data science is about, right? It's about taking data and extracting value out of that data. Whether you call it information or value, doesn't really matter. But that's what it's about. And part of that, I think, was brought up in the panel when we talked about process and behavior in actions. But okay, I think we are going to get kicked out. Thanks, everybody, and we'll be around.
Thank you.